Sorry for the folks online, but also this gives me a chance to give y'all a heads up. We are going to be recording, so if you're not comfortable with your voice or your image being out there on the internet, just feel free to drop stuff into the chat or DM me directly on Slack.
Great.
So
We are now recording.
Awesome.
Cool. So we just had 30 seconds or whatever that we'd started without recording. So we're working on a logo ability, which is basically a little domain-specific language for making art. And we're going to start off and just try and write out an ability where we can make little pictures. So far we have this ability, and we have this turn command, so we can tell the little turtle on screen to turn one direction or the other. And if you want to, turn 180 degrees, you can just turn right twice or something like that, I think. So you're working on the direction there, Rebecca. I think we just have left and right here, right? And then it's like kind of like you have to imperatively keep track of where your turtle is.
Yeah.
Which is going to probably be harder, but should be fun. Should be fun. Cool. Great. Okay, and then I think we probably want to... Well, actually, maybe we start off without it. I was going to say we want to be able to, like, turn off or turn on the pen, but let's do this Etch-a-Sketch style to start. You just have to, like... you just have to make it work.
Yeah, I'm totally down with that. Start simple.
Great. Sweet. So we have both of these. I'll just add these. I think these are good to go for now. Actually, let's move to a new namespace here. I don't know if you can see this, Rebecca, the thing I have on the side.
I can. Great. Yeah, your terminal on the right.
Okay. So we're in turtle, and I'll just add these things. Great. And then we can move these below the fold, which... unfortunately, we still unique abilities and unique types. We have a bit of a problem with Unison right now, where it's possible for them to be updated superfluously and cause a bunch of issues. So generally, with unique abilities and unique types, it's just best to, once you add them to the code base, just tuck them under a fold. But we'll see what happens when we come back and update those later. So now I think we can write some code that draws a picture, and then we'll just have to write a handler for that. So what do we want to draw to start with? Like a rectangle, something simple, a line maybe. Oh, I think we're missing. Oh yeah, can anyone hear me?
I can hear you.
Okay, I think Rebecca froze. So.
Yeah, I think so.
Okay, I think we lost Rebecca. Oh, yeah, she's typing on screen. Okay. We are reverting to instant message chat. Like it's the 90s. Okay, well, I'm going to start drawing a square, I think. Hey, Paul. So our draw square is going to be an action that has the turtle ability, which maybe I'm going to regret making it an emoji, but I don't think I will. Okay. I think we're also probably going to need the ability to step forwards. So maybe we'll edit this ability here. So I will add a step, and let's just for usefulness sake, let's take a gnat here and say how far we want to step. All right, is Rebecca back? Maybe, possibly. Can she hear anyone? Okay. So I notice hopefully we do not have the gnat in scope. So I am going to pull in a version of base. So I'm just going to pull unison.public dot base dot, what do we all have in here? We've got latest main. Let's do releases, and we'll do what's the latest we have here? M4C. And we'll put that in our lib directory. So we're going to do lib.base. And we'll pull that down. Cool. So that should download a copy of the base library. Great. And we notice that nat is now in scope. Awesome. Okay. Great. So I added this step function here. So now we can see we have to update our unique ability, and I can just type update, and it should go ahead and do that. Great, and now I think that's everything we need to be able to draw a square. Oh, I can hear you, Rebecca. Can you hear me?
Okay, good.
Great.
I was hanging out in the background, not wanting to jinx it.
Funny. Okay. Great. So I'm working on this draw square. For those who aren't aware, we have this do command. So this is just a syntactic trigger, which says, hey, I'm going to define like in a block that uses abilities, but don't try to run it right away. We're going to wait until it's like handled by some sort of ability handler. So if you've seen this little tick here, if we do a do block, then we can just write our code in here. So I think we're going to start off. I don't know which direction we're facing, but I guess it really doesn't matter. Let's step, 3 times, and then let's turn left, and then step 3, and then turn left, and okay, what do we have here? Okay, so left, step 3. Hey everyone.
Welcome to the stream.
Mm-hmm. Oh, hey Oliver. How's it going?
Hi.
Okay, I need to visualize. So let's say we're going up. We're gonna go up. We're gonna hit the top left or the top right corner. We're gonna let's turn this to turn right. That's the way my brain works. Then we're gonna go to the top right corner, and then we're gonna turn down, and then we're gonna go bottom right corner, and then we're gonna turn to the left, and then we're gonna end up back where we started. Now, of course, we could do this as a loop, but we'll do it this way for now.
Yeah.
Great. Cool. We can draw a square now. Let's add that. And now we need to actually get some stuff on screen. So this is where the fun part comes in, I think. So let's, what do we want to call this? What do we want to call this thing? The interpreter to turn it into, let's just say we want to get like a single text printout of what we drew.
We could do like to console or to text.
To text. Yeah, let's do that.
Draw.
Yeah, I already have this as draw, I think. Or do we want to like handle or like turtle to text? I don't know. Doesn't matter what we call it. This is Unison. So we're going to say that this accepts some block that draws something. And I think we're just going to return it as text. Great. Okay. There, we implemented it. It's done, right? I don't think so. But what we can do is we can add a watch here, and let's say turtle to text, and we will draw a square. Great. Save that, and we can see on the right we are interpreting it. We're just not actually doing anything with it. So now we need to handle this. So here is our drawing. Let's do handle. So let's handle drawing with H. And now we can define what our handler should be. So let's say H I presume we're going to have some sort of canvas that we're drawing, whatever representation we want to use for that. Yeah, we can think about how do we want to actually like store what we're drawing. Also, we have kind of the situation here, like, do we want to indicate upfront what size our canvas is? Or do we want to like grow the canvas dynamically as we're drawing? Either of those could
That's
be
a great
interesting.
question. If we set the turtle canvas at the front, we could make the turtle on a donut thing and just have the turtle exist in a torus universe.
Yeah, I like that. Pac-Man style. Torus universe, love that.
Turtle on a donut.
Turtle on a donut. Who doesn't like a turtle on a donut? Okay, so we'll take width and height. I like that. Okay, so that'll make our canvas. And then we need to define H. So H is going to be, what is it? H is a handler which takes a, I always forget how to do this.
Oh, here. Oh, it's canvas first. So did we say this was some sort of canvas type? Fill that in there.
Okay, great.
And the base request of turtle. Let me get that.
So we have to prefix request. Is that a new thing, or it's always been the case?
Oh, no, this is a habit because I am frequently in a namespace that has http.request. So
Okay.
I'll show you something though. Let's see if this works. So if I just type request, yeah. So the autocomplete knows exactly how you have to suffix everything. So if I just hit enter here, it knows that request is fine. Yeah, autocomplete coming very soon. Maybe even tomorrow.
it's probably a nicer sentence.
And hopefully we might be getting automatic pattern expansion at some point, but not yet.
So Chris, did I miss what our canvas type was going to be? Was it just like a list of text, or
I'm not sure. I think probably the easiest. Well, okay, we have a couple options. One is we could, because we know the width and height, like we could have just a nested vectors sort of situation.
Okay, yeah, we could do that.
That would probably be pretty easy. Or we can do a map of coordinates to like Boolean or something.
Yeah.
Those
I mean, that sounds nice.
Easy. Sure. Let's do that. That sounds easy.
Okay. Do you want a tuple?
Yeah. That'll be easier to work with, I think. Mm-hmm. And then the other thing, I guess we'll need a position that we're currently at and a direction that we are currently facing. So this will be a cardinal direction, which I think we need a new type for. And this will be up. Oh, are we gonna hit a, let's call this north, south, east, and west. Great. Okay, cool. And then for each of these, we have to handle, okay, so those following along at home, let's explain kind of how ability handling works, I guess. So we've got this turtle ability here, and we can see we've got these two kind of requests that someone using this ability can make, which is to turn the turtle or to step a certain number of steps in whatever direction the turtle is facing. So we need to handle both of these, but how we handle them is completely up to us. So we can interpret them. So let's say we're going to handle turn, and then that gives us some continuation. So this is what's going to run the remainder of our program. And then we put something in here. And then if they say that they want to step, then how do I bind does the end go here? It's been
Yes.
a long time.
That's the argument.
Great. And then this is, I don't know, what do you normally call this? It's called continue.
Resume is
usually?
something. Yeah.
Great. Cool. Okay, so now we've got both of our abilities, and then we also have to handle
Let's add one more case here, actually.
whatever happens if nothing. If we've handled all of our abilities, how do we want to finish off? Yeah. That's very fast. Okay. Cool. So let's say, oh yeah, so and then we've also got to pass our position and our cardinal direction. So let's say we've got a cardinal direction and a position, which I think our position is just going to be a tuple of nats. Great. Okay, so we're pretty much there. Now we just need to handle these things. So what do we want to do when we turn? Are you there, Rebecca? Cool.
Sorry, my internet is pretty rough. Can you hear me?
Yeah. Yeah, you're coming through just fine.
Okay, weird.
Mhm.
So is this function going to go text as the type says, or are we doing the sort of like map?
Oh, good question. I think probably this will return the drawn canvas, and then we can actually like render the canvas, and that should turn it into text. Maybe that's what we'll do. So then this would be something that takes a net and returns, and then goes to text. So then this type, yeah, right, we've got that returning text. Awesome. Okay. And I'm saying this pattern has the wrong number of arguments. Turn. Oh yes, because we need a direction here. And then all of these are expected to have the same type. That is true. So let's just put that in there, and we'll put this in here. And oh no, wait, these should be a canvas. So we'll just return the new edited canvas. Great. Okay. Cool. Now what are we complaining about?
Oh, should this just be map.empty?
Sure.
Okay, and then final question. This is the right order of arguments. Yeah, okay.
Yeah. And then I think we need like an initial position, which will just be 0, 0, and a initial cardinal dir, which way do we want to face? East? Let's try east.
Sure.
Doesn't really matter. Okay, so then this will be initial cardinal dir and initial pose. Great. Okay. Now this is complaining. Why is this complaining?
Oh, because we said this is a map and we're returning text.
That
So we
is,
can do map.empty for all of
yeah,
these
as
if
a
we wanted.
default. Great. Awesome. Great. Okay. Handle with H, and we've got. Oh, I could just have these in the wrong order. There we go. Okay.
Hey.
And drawing.
Oh, we need
Expected
to
type.
force it.
I'm very impressed by the Visual Studio plugin. I haven't tried it, but it's cool to see it in action.
Yeah, a lot of cool developments. Chris has been churning out really cool features there.
Yeah. Yep. Oh yeah, and I have a fix for this coming soon too, where we actually get the documentation and all of that stuff on Hover. So that'll be nice. Okay. Cool. So we've got render canvas. Oh, this should be the drawn canvas. Drawn canvas. Yeah, it's so nice to get red squigglies in the right spots. Great. Okay, are we clean? No problems detected. Okay, great. But this, of course, just bugs whenever it runs, so let's fix that. Okay, so let's start off with, yeah, one of these. So these should be easy, right? So when we want to turn in a given direction, we can do match, too much Haskell. The dir that we want to turn with the current cardinal dir. And then I think we just have to say, well, if we're turning left, and this is just going to be enumerating everything, right? Do you want to help me fill these in, Rebecca? So if we turn left from east, we go north. And if we go left from, let's go south. We go
right from east.
And if we
South,
go
yeah,
left
right.
from... This is definitely a spatial reasoning exercise.
I know. I was so bad at these tests in elementary school.
Something weird happened there. Okay.
Oh.
North. West. Great. I'll let you fill in the rest of those.
Wait.
Okay. So
This doesn't feel right.
Yeah, we need to. Oh, sorry. What doesn't feel right about this?
So turn direction takes a cardinal direction. Why does the previous direction matter here?
Because
if we're taking an absolute direction,
right,
as opposed to like a turn left, turn right.
So our interpreter deals in absolute directions because we need to know the absolute state of the turtle, but the DSL deals with relative directions, which is like confusing, but I think that's how the original logo worked. So when you tell the turtle to turn left, it's just going to turn 90 degrees to the left.
I'm sorry, it makes perfect sense now.
Okay.
I for some reason I read all the lefts as reading east. I don't know why.
Oh,
but, yeah,
yeah, no worries. Cool. Yeah. Also, these aren't like the either left or right for anyone following along. This is a custom cardinal, or sorry, a relative direction that we defined. Cool. Okay. But we can't just return this new cardinal direction. I think we need to continue with our handler. So I think we need to call our handler on the new cardinal direction, but we keep the position the same and the canvas the same, because this doesn't actually draw anything. So we'll do that. Just do some.
Can we just bind that and then do it on a a separate line?
I think we can. Actually, probably we should pull this whole thing out into a new function that, just given a cardinal direction and a direction, just turns in that direction would probably be the right way to go. So let's try that.
Yeah.
Okay, I'm gonna move.
Go for it.
Where we're at here, and then we'll just put this down here. Resolve turn. Great, and let's just change this to cases, because this will be more unison-y. And we'll delete all of these brackets. And we'll say resolve turn takes a direction and a cardinal direction and returns a new cardinal direction. Save that. And then I remove the partial stuff I was doing. Okay, this should compile, but I ruined all of our beautiful work up here. Okay, so now we can say resolve turn of dir and cardinal dir. And this should get us our new direction. So this is our new cardinal dir. And then we'll just carry on with that. New cardinal position and canvas stay the same. Great. Now, why are you complaining? needs to have the same type. Here one is, another is map v. Did I not?
Are you
I need
missing
to
a
call
handle?
resume.
Oh, resume.
So the request comes in last. Yes. So do I need to resume?
I think
But you actually also have to handle the resume.
Oh, yeah. You're right.
I think you want hand width, and then we want to call H with our new order.
Great.
And
Rebecca to the rescue.
Is it PO position and canvas?
Yeah, and just a reminder for everyone who's just showing up, we are recording this, so just be aware it'll probably go up on YouTube. So hopefully everyone's okay with that. Great. Okay, so no errors until we run it. So we've got one of our things handled. Awesome. So let's do step next. So what do we want to do when we step? So I think we probably need to loop over, we need to get all of the positions from our current orientation. And then for each step, we need to kind of increment that position by 1. And then each position that we cross, we're going to set to true in our map. Does that all sound about right?
Okay, let's, just because I'm very forgetful, let's delimit that in some comments.
Great.
Ooh, and we can use. So for step, you said, what was the first thing?
Yeah, so I think we're going to probably like loop over this range or fold over this range. And then apply. Right, and then we'll just like add those offsets to our current position. So we'll figure out which direction we're moving in, and then we'll make range or position offsets for every step along that range, and then we can just fold over those position offsets and set that value in the map. I think that should work. And then we have to know where we finish, which will just be like that last offset. So I think if we compute all of the offsets first, then we can just map our current position against those offsets. Okay, so let's break this down. Okay, so let's make our offsets. So we need to know which direction we're actually changing. Like, first off, are we moving, left or right, like in the X plane, or are we moving in the Y plane? And then we need to know, are we positive or negative in that plane? And we can get all of that information from the cardinal direction, right?
Yeah.
Okay. But I think, do we have like a nat range? Each range, int range. Do we have a nat range?
I just requested terminal access.
Oh. Yeah, go ahead.
Which you don't have to give me, but
If I see any funny business down there.
Yeah, I'm not gonna cat your passwords file.
Okay, so we've got this nat range. What's the type of this guy? Is nat to list of nat. So I think we can start with, well, let's just say we start with 0 and we go to n. And I don't know quite what that actually looks like, so I'm just going to add a watch for that. So nat.range. Let's say we go 0 to 3. What do we actually get? We get a bug because of our other.
We should comment our turtle.
There we go. Okay, so that resolves to like 0, 1, 2, which I think we want probably that to be higher by 1.
Okay.
And that way, yeah, because if you say I want to move by 1 step, we should have at least an offset of 1.
Okay.
Great. So now for each of these, we can do for each, and probably this guy. What is the argument order for each? Takes the handler first and then, oh yeah, this changed in a recent base version. Yeah, but I think I can do this.
Oh, I think you can do range closed.
Oh, is that a thing?
And
Oh, yeah.
All right, cool. Let's see, docs of range closed. What? Oh, do I need to do nat something? lib.base.nat.range closed? Yeah. Right. So it'd be, we would start at 1 and then go to n.
N.
And what happens if we do that for, let's try this. So if we do nat.range closed 1, does that do what we want? If we spell it correctly. Yeah, we still get 1. Great. Yeah, good tip, Oliver. That's awesome. Okay. So now we should be able to take our offsets. So here's our offset, and then we need to do something with that. But we need to know, like, which sort of thing. We need to pair it up into, we need to either add it to the, like, xy coordinate or to, or sorry, to the x coordinate or to the y coordinate. And that's going to depend on our cardinal direction. And then we have to optionally negate it if it's like north or south. So I almost want to do this with like vector multiplication or something, but I don't know that we have any libraries for that. So let's just write some simple helpers. So let's add an add offset to position, and this takes a position, which is just going to be a net, and it takes a cardinal direction, and then it returns the new position.
I'll let you fill that out. I don't want to run into you.
Sure, I'm going to probably do one of these. And then this will be this net. Ooh, can I do this? Is that a thing?
Yeah.
Great.
Yeah.
Cool. We'll bind one at the top and everything else. Actually, well, I should be able to. Oh no, I can't do that. Okay. Great. So.
Ooh, do we also need the window frame max height and width?
Oh, if we wanted to wrap around.
Or we could do something simple and just say, like, if you're at the top, you temporarily, turtle just stops.
Right. I think we can do this. We can just have it like move the position, and then, oh, does that work? I mean, we could do the modular math really at any point. Like we can do that in the handler, or we can actually even do it when we draw the canvas, and it should all work out the same.
Yeah.
Yeah, and then it might be easier to switch to other types later. But yeah, we definitely do need to do that. You're totally right.
That's a good call.
Okay, so now what's our coordinate system? Is 0, 0 on the bottom left or on the top left? Because I know that's always a... Maybe bottom left? Let's do bottom left.
Yeah. I'm going to make a note that net still starts with
oh.
0.
Okay, now, but these are nats. So you might be right, actually, we do need to do the modular math here because we're using nats instead of ints. Or should we just use ints as our position?
I think now that we've established that we're not going to do the truncation here, we should use ints.
Okay, I think that makes sense. Our offset can still be an at though. There we go. Okay, and then
I'm
Yeah,
going
you
to
got
change
that.
all
Okay.
of these to int as well.
Great, thank you. Okay, and then if we go east, then we change the x, and that's going to be plus the offset. And if we, that's going to be minus the offset. Great. Okay. We've got this awesome thing, and we're failing here. So now for each offset, we can add offset to position where we have the offset, and then the cardinal direction and the position. I don't remember what order those go in. Position, then cardinal direction. Oh, whoops.
Oops.
I'm lost. Here we go. Okay, position, cardinal direction. Great. Okay.
So
But I expected
I'm
that.
kind of curious. So right now we're ranging over the number of steps, but could this have been on this step where we just keep lowering the number?
Could this? Sorry, can you say again?
So instead of, I'm not suggesting we do that now, but I'm just curious. Could this have been a recursive call on the step ability function, where we just keep calling step by lowering the number?
That might actually be easier. That's true. Like we could actually change the step ability, or we could change step to not even take a nat, and then you could write step many in terms of step.
Oh, yeah, I kind of like that.
Yeah, it's a simpler interface for sure. It'll be potentially slower on some backends, but who cares about that right now? So.
Or even if we didn't want to go that far, could we call? We could just call step recursively here, right? Like even the regular step ability function.
Yeah. Like you're saying, drop if this is like we could pattern match on n and see if it's greater than like one or higher, and then move it and then subtract one. Yeah, we can totally do that.
I'm not suggesting either one. Just just thinking through it.
Oh, let's try that. Because that would also allow us to change this later if we want. So if we say match n with, or can we do this here? Can we do this with different? I think so, right?
In an ability handler pattern match?
Yeah. Can we not do that?
I mean, it is a pattern match, but
let's find out.
I've never been sure about how faithful it is to the regular pattern match abilities.
Well, maybe we get a bug report out of it.
Yeah, maybe we're discovering new things every day.
Totally. Okay, so let's do it. Let's try this way. I like the idea here. So the idea is, I guess our offset is always going to be 1. So for now, I'm just going to do this. And then we get the new position out of it. So there's no for each. We don't need that. We don't need this range. Good. And then this should be the new position. And then we need map dot, what do we want to do? Insert. Because we don't care what was already at this position. We just want to set it to true.
Yeah.
Okay, so it's key value is true, and the canvas is the thing. And that's our new thingamabob, and then we can... Okay, so but now here's the fun part, is when we resume, we actually, I think, need to resume... Okay, no, we need bang resume and a step. Is that right, Alvaro? Something like that?
I think so, except you gotta do the step n-1.
Oh, yeah, right. I still need an int here. Or,
And I don't know, does Unison have semicolons like that?
Yeah, I think you can just do it up here, like.
Just suspend it?
Is that going to be handled if we do it up there?
No, I think you have to create a new one,
Yeah.
a new resume that's suspended.
Okay, let's try this then. So if we do step n-1 resume new action, that should work.
Yeah.
Okay.
There's
Great.
an error in line 16.
Yeah, what's going on
So this
here?
should just be the same cardinal direction, right? In this case, you haven't actually turned.
Yeah,
Yeah.
great.
This is kind of cool because I feel like in a way we're rewriting the original code by adding prepending the step n1. It's cool.
Yeah, we're reinterpreting an ability call in terms of other ability calls within the same ability. Which is kind of interesting. Cool. But yeah, and this also makes it way easier. If we do decide to get rid of the n or whatever, we can just delete this case. And then this n goes away. Cool. Okay, and now we've got pure empty. Let's see what this actually outputs. So can I do bug of drawn canvas? Does that work?
Do you want to like see it? You could do trace.
Oh, we have trace now. Yeah.
And then you'll need a text argument. It's like, hello.
Great. Okay. Now we add our turtle thing back.
Turtle
I'm gonna
watch,
put this at
yeah.
the top. So I know where to find it. Okay. Trace canvas. It did not actually render it out. That's interesting.
Is it?
Oh, or do I? Oh, you do it twice. Is that right? What is this?
Is rendering tip? Is that an empty map? What is tip?
Oh, it does render it. It is empty map. It's this tip
Oh,
thing.
tip. Oh, good call, Oliver. Yeah.
Yeah, I didn't see that.
Great. Okay, but why is it empty? It should not be empty. So we're passing in the empty canvas. We get the new canvas by inserting into the old one. We pass the new canvas along, and then we return map.empty at the very end.
Yeah.
Okay.
Oh, and let's do
Okay,
it.
it's still trace calling F. Oh, did you find something? Yeah.
Okay,
Great.
there we go.
We got some stuff in there. Okay. Terrible rendering, but is there like a map dot?
Yeah, there's a map to list which helps
So
make it prettier.
Draw list. Yeah, map dot to list. Okay.
Yeah.
Sure. Much better.
There we go. Hey.
Okay, that doesn't look quite right.
Indeed, we wanted to move 3.
Well, so are we actually applying this to the correct position? Oh, sorry, what were you saying?
Oh no, I think we're thinking along the same.
Yeah, we need to alter our current position
Yeah.
to the new position. Much better.
Hey. Okay.
Okay,
Yeah.
I have no clue what that looks like, so let's let's figure out what that looks like. Okay. This could actually just be a set rather than a map, actually, but whatever.
I think I just like the access functions on map,
map
more.
better.
I don't
Fair
know.
Well, what would we
I'm
actually...
open for interpretation.
Yeah, sure. I think all we would need is like set.insert and like set membership check, right? And that gets us
Yeah.
that Boolean. But anyway, let's leave it like this for now. Maybe, because like, eventually we're totally going to add color to this thing. So we're going to need to store pixels in there, right?
True.
Totally.
Yes. Totally.
Totally. Okay, so we're super close. Now we just need to actually render it. Oh, I'm gonna make a checkpoint. We're gonna add all of this.
Good call.
Update. There's nothing. Are you sure?
Do you want to also
Oh, I can't do it.
do
when
we
it's
want to keep
above.
adding cardinal type?
Oh, is that up there still? Okay.
Yeah. I mean, it won't do anything bad, but
Okay. Oh, I need to add it at least
Oh.
once. Okay, 1 second. I'm gonna undo. Oh. Okay, so let's make it so it actually compiles. Great. Okay, let's add all of this stuff. Great. And then, yeah, let's move the types down there. Great. Okay, we're in good shape. So now we can implement render canvas. Where is that? Here it is. Cool. So this will need to know our sizes. Okay, yeah, when did we want to do the modular arithmetic? We can either do it on the positions. I guess just on the new position is all that we would actually need to do it on, right?
yeah.
Should we do that? So this will just be if it's negative, if either of them, oh no, we just do each one mod, like X mod width and height, Y mod height, and that should work, I think.
Yeah, that'll give us the remainder, and that's the actual new position.
So if we do new X and new Y, and then we do nat.mod, which I don't know which argument goes where. Docs is dot nat.mod. Dividing X by Y. So it should be, is this right?
I interpreted it as the other way, but
You could very well be right. Let's test it and find out.
okay, yeah.
Okay, so let's add here and say nat.mod of, okay, so if we go negative and our width is 10 or whatever, we need to be compiling. No, we don't. There we go. Why are you complaining?
-1 is not natural.
It's not a nat.
Yeah,
we want
so
int.
we can do int.mod and then just turn our width into int.
And then this needs to be a plus. Great. Okay, and then that goes to +9. Yeah, okay.
Okay, yeah, you're totally right. This is the right.
Okay, cool. So current position first, width +1 second. Is that right?
Where are you?
Oh, everything is under a fold. That's the problem. Okay. All right, where were you working? Yeah, here we go.
Okay.
Great, yeah, that looks good. And then we do the same on int.mod new y to to int height. Okay. Great. Did that fix wraparound? We'll never know. But we don't have to worry about it. Okay, so now we know if we do this, well, we probably still want the width and height in render because we're going to need to know how many characters to render.
Yeah.
Okay. Great. And for this, I think we can just do. Can we do an each here? Each dot range over the width and range over the height. Although maybe.
Yeah, we could.
That seems like
we
the hard
could
way
use
to do it.
to get just a combination of like X and Y coordinates for the entire thing, or
Yeah, but we do need to know when to like insert new lines and stuff. So
I was also thinking that mod on int will produce negative numbers.
in which case?
Where we're doing the new X, new Y.
Okay, so if we do int.mod, but you're saying like if we do like -10 or something, or like
yeah, but on the second parameter we do a negative.
Oh, well, in this case, the second parameter will always be positive because it's a width or a height. Yeah. So this should always output a positive number.
Makes sense. Yep.
Yep. And we're constraining that with we accept the nat here, and then we only convert it to an int when we do the mod. So.
yeah. But Alvaro, that's a great thing to point out.
Totally. Yep. I love. I can watch Rebecca type in the error output because it's outputting diagnostics fast enough. That's great. Okay. Great. Okay. So, but yeah, we can do each line in each character, and we probably could do it this way. We just can't nest the eaches, so it's probably easier to just do a for loop, honestly. So let's say.
I think. Hold on. I think you can. Like, I feel like this is a good use of each.
That's right. So, okay, so if we do each dot, I wish this showed the docs. I need to add that.
Yeah, I'm looking at the docs literally on Unison Share right now.
Yeah. Okay, so we need to. Oh, is there an each dot range? I think there is. Right?
Yeah, there is an each dot range, so we could do each dot range 0 to, I think it would be like height plus 1, assuming. Well.
I don't. Yeah, I think it just be 0 to height, right?
Each dot range I_j generates the values from I up to, but not including j.
Mm-hmm. Right, but
yeah, okay.
But if we want it to be 10 pixels, then and 0 is one of the positions, right? We would still have 10 if it goes from 0 to 9.
Yeah.
Okay. So we can get our line that way, but then like what I'm saying is we can't do that for column. Because, like, well, I guess it depends on how you were planning on building up the text. But we could do a nested each, like we can do an each.toList and then put a do in here. That would work fine.
Yeah, maybe I think I've misinterpreted what you were trying to do, because you can do.
Yeah, line. Go for it. Show me what you think. Oh yeah, so
do we just want?
Well, we need to get text out at the end of the day.
Gotcha. Okay, I think I've misinterpreted what you were trying to do here. So why don't you, tell me more. What's going on?
Okay, so I want to build up the text line by line from top to bottom of our canvas. Does that make
Okay.
sense? And then we can just call like unlines on it at the end. So
Gotcha.
what I was thinking is to say, okay, we can use this each to list, and then our and this will give us the list of, for each line, we want to get all of the columns. So this will be like, okay, so for each column, then we look up in the canvas. Is there like a default lookup of some kind? Default. No? Oh, I guess we can use optional default or whatever, right?
Oh, like map.get or?
Oh, is there a get? What does that do? What's the difference between map.get and map.lookup? Are they the same? They seem the same.
Let's see. Get returns an optional. I'm not familiar with map.lookup.
Couldn't find matches searching map.lookup. They look the same. They might even have the same. I wonder if they have the same hash. Let's find out.
I mean, it looks like they have the same type signature. So go
They
for
have
it.
the same hash. They are the same. Okay. Anyway, so let's do map. Oh wait, but is there a get?
Names don't matter.
Get, but there is a get or else, and there's not a lookup or else. So we are going to use get or
Ooh,
else.
okay.
Okay. So then we say we want to get the line number and the column number, and if we fail, we will return false. And we'll run that on the canvas. Great. And then we can just say if that, then I don't know what we want to fill them in with, something like that. Or we can just draw, we can draw turtles everywhere. Oh, if a turtle counts as a character. Well, it seems like it does. Oh, how do I do a space?
Oh,
Do I do
I
that?
guess. Sorry. Oops, sorry. Am
Uh,
I typing? I'm typing in a weird place.
Yeah.
My bad.
You're up there.
I was
No.
trying to do /s, and instead I have typed. I think it's because I'm following your cursor and I can't stop.
Oh, I can't stop.
I tried. Let's see if I can fix this. Is this any better?
Oh, am I following your cursor now? That's weird. Oh, yeah, I am.
Yeah, are you following me? I forced you to follow me. I'm
Oh.
sorry.
I'm like, let's go. Oh, yes. Rebecca focused my attention. Yes, she did.
Oh no, okay.
Okay, we are following each other. I am deleting you as a...
Oh, I've been removed.
Oh, no. Oh, that's not what I wanted to do. I mean, it probably has a part of the desired effect, but has the undesired effect of Rebecca won't talk to me anymore. Sorry, can you...
I'll
does that
rejoin.
link? Yeah, try the
That's
link
great.
again. That's funny.
That's what I get for focusing the stuff on me.
Yeah.
Okay, let's see if... Okay, I think I'm back.
Yes, Rebecca has
Awesome.
joined.
All right.
Great. Okay. Okay, and hopefully we're not following each other. Oh, you're following me. Do you want to be following me?
I mean, at this point, I think I'm okay with it.
Okay. I'm not following you though, I don't think. Okay, what were we doing? Okay, we're getting an error here. Oh, we can't have a doc here because
Oh,
that's
okay. Here,
annoying.
we'll just move that up
Yeah,
into this doc and
it's a doc
not
and a doc.
transclude it, which you can do.
Elf on a shelf. Great. Okay, cool. Where were we? We were trying to make a space here. Okay. If get or else third argument has type map. Why did you expect that? Did I get these in the wrong argument? Yes, I did. Here we go. Okay. Oh, you're still mad at me. third argument. Oh, int boolean or nat boolean. So these, yes. Okay, so we're going to here. Let's range over ints. Or does, oh, range only takes
Ooh,
nats.
I don't
That makes
I
sense.
don't think range takes, yeah.
Yeah, we'll just have to do it here. Is that right? No, everything is very angry. Maybe that means that it worked and the type checker just got further. I think that might be the case. So I don't think we want that anymore. I'm just gonna put this here to make
Yeah. Placeholder.
it happy. But oh, and then we just need a text.onlines here, if that exists.
I'm not familiar with that. Is that a thing?
It might be. Do we have an onlines? Following were not found. Really? We can make it.
Find
Oh,
unlines?
find onlines.
Yeah, I'm not. Is this a
Interesting.
Haskell
Okay.
function?
Yeah. I just kind of expected it to exist. Let's see what's in lib.base.text. It just joins things together and inserts new lines in between. So we can write it if we.
I think that function exists. It's just called something different.
It's probably got a better name.
Yeah, I think it. My personal opinion.
Oh,
I
there
think
might be like a
text.join.
join with, or it might be intercalate or something. I'm not seeing anything. Anyone aware of a function like that? Do we have intercalate? Oh, it might be. There might be oh no, but we don't have monoids, so we probably don't have intercalate.
We have. Is it text.make lines? Sorry, my UCM is not.
I have it on my own code base.
Okay, yeah. It looks like it doesn't exist, so we're gonna need to make it. Join. So we can map over everything, add the new line, and then call join. Oh no, join takes a.
Join takes a character separator. So yeah,
Great.
it is just text.
It's just text.join. Awesome. Okay, so this will be text.join new line. Or new line.
It takes a text argument, so
good.
it will be, yeah.
Great. Okay, perfect. Okay, so then that should work. And then we just need to. These should these be texts as well? Yeah, these should be texts.
Yes.
And then we can do the same here, which is just a text dot. Is there a join that doesn't take a separator, or do we just do that?
You can just do empty string. Yeah.
Or it's probably like concat or something. No? Let's see here.
Let's see.
I'm sure there is one. Who knows what it's called? Not important.
Oh, just plus plus. I'm sorry. I'm brain
Oh,
farting.
but that's I want to concatenate a list of things, so I still need join, I think.
Okay.
Yeah. Okay. So, but that does seem to do something, and I think we are compiling. No.
Is it?
First argument to render canvas has type map, but I expected. Okay.
Oh, we need to put in our width and height.
Yes, please. Go ahead.
Okay. Let's do width and height. Okay.
All right. And then we save.
I
Okay. Oh,
typed in
yeah.
X.
We got it.
Sorry, that's
Extra X. Okay. All right.
Okay,
And
ignore
now
my.
change our watch expression. Wherever that went. Here we go. So, what did we want? We wanted to, I don't even know which functions we have in here. We've got turtle to text. Okay, let's draw a turtle to text. And let's just do it on a 5x5 of our draw square. What's gonna happen? Oh, okay. So
Okay.
that's
It's
something.
beautiful.
So now
Yes.
let's do, we can't do IO in a watch, can we? I don't think so. So
No.
let's do a print Oh, no, wait, we can just assign this. So, like,
We can just do a run main.
yeah. You're saying do this, and then do we have like a print?
Print line, yeah.
Yeah, that'll probably do the right thing. And then we'll do turtle text 5 draw square. Okay.
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 Okay. It's
You're off by
abstract. It's
one
a
or
really
something?
interesting
It's
interpretation.
beautiful.
It's beautiful. I love it.
Okay.
Nailed
well,
it.
Nailed it. Okay. Well, we shouldn't go up to +4 here, so that's a problem.
Yeah, we're off by 1.
I wonder. Okay, I'm a little suspicious of the case handling on that n=0 thing, but we should just start digging through here. Okay, so is our map already bad? I think it is, because we should go from 0 + 4. Yeah, I don't know what this is doing here.
Oh, sorry. Where are you looking at?
In the terminal. Oh yeah, sorry, you probably can't see. We
yeah.
have a +4 in the map, and that doesn't seem right. It should go, well, we started 0, and then we should go +1, +2, +3. Yeah, like, why do we have +4s on the Y side but not on the X side? And why do we not have any +1s on the Y side? We're skipping it.
Yeah. I'm gonna write a simpler draw, which is just like draw line.
Okay, that's a great idea. But our X's and our Y's should, in theory, be the same.
Yes, I agree. Yeah. So I'm gonna do.
Oh, I wonder if I'm just gonna double check our add offset and our resolve turn, because spatial reasoning is hard. East, south goes to east, west goes to south, north goes to west. Right from east is south, right from south is west, right from west is north, and right.
I think we need to -1 on the width when we do the mod.
Let's see, when we do the mod.
Wouldn't we expect the same problem on both the height and the width if that were the issue?
It depends on what the steps are.
Yeah.
I don't know what the steps were. Well, do we take the same steps vertically and horizontally?
Yeah, we should. So what I'm running here is just a square. So we step 3 times, turn 90, step 3, turn 90, step 3, turn 90. Oh, I wonder if we are going off the screen, and yeah, because this is a square. It's just a square on a donut.
Yeah, you're off by 1 somehow. Like you're one to the right of where you should be.
Well, yeah. So which way do we start facing?
We start facing right according to our initialization.
Okay, so if I change these to lefts, let's try that. And then let's run main.
Oh, you want to draw a square instead? Hold on. We gotta.
Oh,
okay, try it again.
Okay. Well.
Okay, well, it's looking more square-ish, so I'm not mad.
I'm not mad. I'm just disappointed. That's all. Okay.
Let's see.
Okay, so if we start facing, what is all of our initial stuff here? Initial position is 0, 0. Initial cardinal direction is east. So if we step 3 and then turn left, So we're facing east. We turn left. We should be going north. Then we step 3. And then we're going north. And then we turn left. We should go west. Step 3. We're going west. We turn left. We should go south. Step 3. Yeah, okay. So that's all right. Oh. Okay, well, one thing is we're drawing it upside down. But that's, it should, I mean, a square is symmetrical, so. Right, because our canvas is 0, 0, the origin is in the bottom left, but because we're drawing our text from top to bottom, it'll actually flip it.
Okay.
Does that make sense?
Yeah, no, that makes sense. And I think that is a problem we should solve. I'm just not sure that, like,
I don't think that's the problem.
yeah.
I agree. But that is also easy to fix. I think I just flipped these two, right? There we go. Okay. This should be no different. And
It is different.
it is different. Are we
It is
rendering
late.
things sideways? Are we doing each properly?
Oh,
Oh, I wonder
that
if
is an
this
interesting
is like
theory.
weird nesting or something. I'm concerned.
To list.
Okay, so for each column that's 0 through width, we get the thing at the, oh, is this the right coordinate order? This is backwards. I have my X, Y in the wrong order.
Yeah,
That's one
and
thing. Let's try that. Now we have an even more different square.
I love it. I love this Picasso interpretation of squares.
We're
We're really
getting
pushing
there bit by
geometry
bit.
into a new direction.
Hmm.
Each line is equal to 0 to height. So this is line supposed to be y-axis?
Yes, it is. Yeah.
Okay. This is y.
Yeah, let's just call it Y.
Yeah, let's call it y.
Let's call it Y. Okay.
Yeah.
And then column is X. Okay. So get or else X. If it exists, then we render a turtle. And then, okay, I'm just going to do this because sometimes terminals don't love emojis. Okay. That's easier to see. So it's very easy to see what's going on. We definitely have a square. Our like spacing or whatever is just off.
Okay. This looks like an issue in our wraparound logic, but
It's either an issue in our wraparound logic or like we're either starting facing the wrong way or something, and then we just like immediately go off the edge when we don't expect to. So we
okay,
start at
let's
0,
instead of
0.
a square,
Yeah.
what if we choose L as a shape? Because L has
Yeah.
a directionality.
Oh, yeah, yeah, yeah.
where, like, maybe it'll make the problem more visible. So this one is step 3, we're facing right.
Yeah.
And then turn left. So we're gonna face up, and then step 3. So
Yeah.
we should.
So that's right.
Okay, so that's right. We just have a
Well-
weird.
Well, yeah,
space.
yeah, because like we're starting here. Oh, yeah, yeah. Well, this is now that I've switched it. So like we start. Oh, you can't see my screen.
I can't see the screen.
Yeah. Well, we start on this top left, and we do the 3 to the right, and then we turn up, and then we wrap around up from the bottom. So
Wait, say that one more time. I'm sorry, I missed that.
So that is correct. It's just we're starting on the top left rather than starting on the bottom left.
Gotcha.
So
Okay.
this is actually completely correct. This is correct. So if we
So-
change that to a turn right, we should.
Does that mean that the previous drawing was also correct?
It is very
If we
possible. Yes, I think it was because. Yeah. So if I turn these back to right, it's because we were rendering it upside down. So now that I fixed that, I just need to reset everything. Okay, and let's change this to draw square. Sorry, I'm getting excited. Look at that. Okay. And there's a square! I can't hear anyone cheering.
Woo!
Yeah,
Well
okay.
done.
We got a square. Great. So let's add that. Update. Cool. Hey there, Rebecca?
Hello?
Oh, hello. Oh, did we lose Rebecca? I heard her say something, but now she's typing. Hello. Yeah, I think people can hear me. I just can't hear Rebecca. Okay, we will hold for a couple seconds for technical issues. Get Rebecca to try joining again. Okay, she's gonna try rejoining. Hello.
Hello?
Hi, can you hear me?
Yeah, I can.
Great.
Okay.
Okay,
This is my end.
that's unfortunate. Okay, but we're drawing a perfect square. Look at that.
Missed the square.
Oh, well, it's in the history. You can scroll back and see it.
Okay, I see it. It's a beautiful square.
Beautiful, beautiful, beautiful. Okay, so, and we're drawing it of the appropriate size and everything. So, we have everything we need. I don't know. What should we attempt anything else today? Should we leave it at that and pick it up again next week? What are you thinking?
Should we do one test, which is our wraparound logic?
Yeah.
Just like send the turtle 10 steps to the right and then set the screen width to 5 and just make sure it's just one line.
Sure. Yeah, sounds great. Let's try that. So, if we just do, is this going to work? If I say map nat dot range 10, and then we say inside here we can ignore the argument and we just step. Or do, oh no, wait, we can just say step 10. What am I doing? Step 10.
Yeah.
Yep. So we only get 5.
Okay. Yeah, 5. Perfect. It's beautiful. Let's turn our cursor back into the turtle.
Yeah.
I'm still a little skeptical. Can we can we start it in the middle and then overflow the canvas?
Ooh, that's a good test. I don't think our API for the ability
Yeah,
itself is expressive enough.
So if
To
we
do
want
that,
to, well, we can change our initial position. Here we go. So
Oh,
let's
that's a good, yeah, we could change our,
let's start at 3. And then we just want to still see the same row of turtles. Seems to work. Although our turtles, I don't think are rendering in a fixed width font, unfortunately. So that's probably going to cause us issues down the line.
But can we render it in a way? Because I'm so worried. Can we render it in a way that it breaks up the line? So start it from the middle. It wraps, but it doesn't quite reach the tail.
Sure. So let's, instead of stepping 10, let's just step 5, but we're starting, or let's just step 4. So we're starting in the middle. We should have a little hole in the middle of our line. Yeah, there it is.
oh, it's a train.
Great, that works.
So yeah, they're all going to school. Great. Yeah, and we can see here too. We start at, oh, so one thing is that we're not drawing a turtle on our starting position. which I wonder if we should do. I think we should, because that's unintuitive. But I think we can just start with our canvas as, instead of map.empty, we can just do a map.insert
Initial position and then true.
true. And then that should make that work. Yep. So we're starting there, but we're only moving 4 steps. Right, yeah, but that should make a full line. Because we have our start position, and then we go 4, that adds up to 5. So if we switch this to 3, great. And if we only step once, we should see 2 turtles. Yeah. Great, yeah, that's better.
I dig it.
Thanks, Silvero, that's a good catch.
Yeah, that was a good catch. That was a good test.
Okay. So I wanted to see if we could write a handler that prints out every step along the way so we can like animate the drawing so we can like see the little turtle walking around.
Yes, I love this plan.
I think that would be fun. So I think we can mostly just copy paste the existing handler that we have. We just need to accumulate the maps along the way. And then we can just render each of those steps.
Yeah, what if we emit each map in a stream and then interpret the stream into a list?
That sounds great. That sounds like a really good and easy way to do that. Okay, take the lead.
Do we want a separate handler or to alter turtle to text?
Let's just make a copy of it.
Okay. Turtle. Ooh, it's not gonna like the duplication. Turtle.
Okay, where should I be looking here?
I am on line 31.
Gotcha.
So turtle to stream. Sure. Okay, so I'm going to say this thing is going to, at every step, emit a map of int Boolean in the process of returning the final text kind of canvas.
Sure.
So
yeah,
we can change this.
No,
as we need.
that's great. That's great.
Okay. And our handler signature is also going to change this little H guy. In that, it is also going to be emitting that. This is a little unlovely in that it's duplicating both the stream and each successive thing, so we can think about that later. But let's just do a stream.emit during our step function.
Oh, yeah, that's a great idea. Because we only need to emit whenever we've actually moved.
Yeah. And if we stream.emit the new canvas, capital S, so that will stream the new state. It won't necessarily stream the initial state, but
right.
I think that's okay.
Can we just add a stream.emit initial canvas at the bottom?
Yes, we can.
And that should still run in the right order. Yeah.
Yes.
Oh, we shouldn't call it empty canvas, probably.
Yeah, we should call it initial.
Yeah. That's...
Okay, let's do emit the initial canvas, renaming that.
Awesome. No problems.
And when we get to the final 0th step here, let's think. Do we need to do another emit? I don't
I
think
don't
so
think so.
because we've taken care of it here.
That's right.
Okay. Cool.
Great.
So
this is going to now need to be handled when we actually call this.
yeah, I think I'm gonna call this turtle to stream prime.
Yeah,
Um,
I see what you do. I guess it depends what we want the output to be, because we could also probably just add this at the top here and then change the type signature, but I'm fine with that. That looks good. Keep
okay,
on going.
yeah.
Mhm.
So I'm gonna call this turtle to stream with Python, and we're gonna do stream to list. And this will return an evaluated list. So I think those types might match up. Let's just double check by making the UCM tell us by writing something wrong.
Yeah.
Oh, my console doesn't update for that.
Oh, right.
That's okay. There we go. Yep, that looks about right. And I'm gonna get rid of these little generic ability requirements.
I love our little turtle in the ability list, just hanging
It's
out.
beautiful. Okay, and
And I think,
this
yeah,
needs
we
to
just
be-
need, that's text or A, I guess. Either is fine.
okay.
Cool.
This should arguably be turtle to list.
Indeed, it should.
How does one turn turtle into a list exactly?
With this function.
Yeah, turtle soup.
I mean, it's more like a
Beautiful soup.
scan, like a scan left or like a,
Mhm.
but yeah.
Okay, so now that we've got this list, should we just have this return the list of texts as well?
Interesting.
Or should we make another, or like we can also just do that down in main if we like. So we can, let's try it. Okay, so let's
Okay.
comment that out. So we'll add a turtle to list, and this will get us our list of turtles. So incremental drawings, I guess canvases, and third argument has type unit, but I expected text. Oh, yeah, okay, so the turtle to list, yeah, it does have to take an A here. Good. Okay, and then I think we can just take incremental canvases, and map that with render canvas. And what's the problem?
Oh, render canvas takes a lot of arguments,
Oh, right, we need
the width and the height, and then the canvas.
Great. And then we have a list of texts. And I guess how do we want to... Ooh.
Okay, so I feel like Stu has this ANSI library where you can clear the terminal, and then because we have IO, we could just,
Yeah.
do a little delay.
Yeah, that's a great idea.
So I think that'd have to be though in this map function, yeah?
Yeah. I guess we could also, like, rather than turning them into a list, like, we could, in theory, like, stream them as we're computing each one, but like this is going to be so fast it really doesn't matter.
Yeah.
Okay, but I'm going to pull stu.public.anc. Are there no completions? No. Let's see. Does he have this public? He's got it under projects, that's why.
Public base.
Let's see, latest. We'll put it in lib.anc. Okay. We have the ANSI library now.
Okay. I'm looking for the sleep function in IO, and I'm
Oh, it's called delay.
delay. Thank you.
It looks like there is also just one called sleep under concurrent, but
How come? Let's see. Is it just called delay?
yeah, lib.base.delay. Oh, but that's
no,
a different
that's-
thing. I think we want just sleep.
Okay.
Yeah, there you go.
And
What
how
does delay do?
It looks like it converts a function into a new function which delays the return value. Interesting. Yeah, that's maybe not a great. Well, I guess it depends on whether it's a good name or not. Also, I wish sleep either took a duration. Actually, I wish sleep took a duration. It should take a duration.
Yeah, what's the unit in sleep?
Yeah.
Is it microseconds? So if we do 1,000,000, that'll be once per second.
Is it yeah, it's microseconds. Okay, we should have a type on that. Okay. Great. So we're mapping, let that, and then cool. Okay.
Then we want to did you do the clear or find the clear terminal
I
character?
didn't. Let's see. Find on view lib anc dot
Clear all. Yeah.
Cool.
So before we sleep, maybe after we sleep. Clear all.
Yep. And that's just text, so we need to actually like render it. I wonder, maybe there's a better way here. Let's see. If I just type.
Looks like I just had an old version of base because delay for me looked the same as sleep, but not anymore.
Yeah, it was
Things
recently
change.
updated.
Do we have to print line this? Is there just a print?
Oh, I think you're right. I think we have to print the text.
Yeah.
Okay.
Maybe we should clear and then do that.
Okay.
Oh, whoops. Why does that not work? Oh, because this isn't a complete thing.
We're missing.
We need to bind our argument, I think, right?
Yes.
How's that?
Ooh, okay. Moment of truth.
Burp.
Ooh.
Okay.
It moved twice.
Right.
Is that
and
what
yeah, because we're only doing a step one, so it'll render the initial position and then the other. Let's draw a square.
Okay. I was
You're like,
did we introduce regression somehow?
what did we do? Okay, let's try again. It also does not appear to be actually clearing, but I wonder if we need to do something special for that, like run it from not UCM. Oh, did we get a regression on our draw square?
I feel like now it is significantly weirder looking.
What makes you think so?
you now get turtles between other turtles. That's a little bit concerning.
Yeah, I think the
And it's a
spaces
proportional
are.
font, right?
Yeah, it's not a fixed width font, so that's a problem. But okay, let's see if our original one
It's-
draws a square properly.
It's printing letters though. This says IC, like individual contributor.
Yeah. Okay. Wait. What happened to our? Oh, did the square only work when? Wait. Why is this broken now?
Okay, I think it's
I'm gonna try this again, but.
Oh, did we remove the changing of the initial
Oh,
position?
yeah, the initial position. Thank you, Alvaro. That's exactly it. Okay.
oh
So the. Wait. Oh, yeah, but it's copy pasted
yeah
twice.
yeah that's correct. We should
There we go.
have the initial position be an argument.
Yeah, I think so. Okay, let's do that. Let's do that.
Okay.
Internet students. Okay. And then I'll make the same change here. Okay. And now we need to add these arguments here. And here. Okay, so now we should be able to draw a square. Great. I'll switch it back to turtles in a second, although the turtles are a little problematic because of the fixed width font issue. Unless we can find an emoji that represents emptiness. I'll leave that as an exercise for the reader.
We can totally do that.
Like
We can use the square box.
Yeah,
Let's make it look like a
big old black square,
okay. I'm gonna turn this back into turtle
red flag.
and
Okay,
let's
and then let's
do
switch back to incremental canvases.
that's a good where'd that blank thing go? It's under squares. Aha.
Yeah, this did something interesting.
It did do something interesting.
Okay, so we go all the way to the right. I think we end up back where we... No. What? Oh, is this clear? Wait, is it clear all doing something weird? I don't think so.
Hmm.
Oh. Okay. It's still going to do something funny, though. No, that's right.
Uh-huh.
Okay. Great. Delightful.
Okay, so the clear all was doing something very strange.
Yeah.
So,
Hmm.
3, 4, 5. Oh no. I must have just run it while you were editing something, that's all.
I think that's what it was. I was in the middle of an edit.
Okay. That's great. We'll do that. We'll add everything else. Okay. Cool. Great.
Hey.
Now we have little turtles that live in little squares. We're not properly, like, the clear all doesn't actually work, but I wonder if I run this, like, from outside of UCM. So if I make a new...
Oh, well, we could show that.
Let's try a UCM run share.turtle.main. I think. Is that all I need?
Is this new functionality? Maybe it is.
Oh, so still not clearing things. Let's look at the docs for the ANSI library. No, we've had run for a very long time.
Okay.
Yeah.
I wonder if printing
well.
clear all is different from.
Yeah. Well, like it's gonna add a new line for sure, which is already not ideal. So, does he have docs for these? Let's see. got main, we've got dim, we've got clear all. I don't actually know what these ANSI codes are. 2 and K. Main.code. What does main.code do? Okay, so we've got this. Next character. Okay, so we've got character 27, and then don't know what this is doing. Oh, this is the like left carrot. What is this? Oh, this is part of the list. Okay, so 27 left. So this is the escapes starter, and then we run these codes. And 2K do what in ANSI land? Okay. I mean, searching for escape codes is not gonna maybe be the easiest thing. Yeah, no luck there.
Yeah, I'm like furiously Stack Overflowing over here.
Erase in line. Erase is part of the line. Two, if n is missing, clear from the cursor to the end of line. If n is 1, clear from the cursor to the beginning of the line. If 2, clear the entire line. Okay, so this clears one line. So we would need to like do some n curses like deal. There might be a way. So I don't know. Let's see here. Erase in display. Clears part of the screen. Is that what we want? If n is 0 or missing, clear from the cursor to the end of the screen. If n is 1, clear from the cursor to the beginning of the screen. I think that's what we want. If 2, clear the entire screen. And moves the cursor to the upper left. Great. Okay, we want this one. Which I don't think is in the library, but we can just kind of hack it in there, I think. Yeah, so if we do a clear screen and just say this is, oops, main.code. Why is this not auto? Oh, it's not auto completing because did I kill my other terminal? Hello? There we go. Oh, there's no main. That's why it's just code. There we go. Okay, code, and we want 2. And what was the magic? J. Let's try that.
Okay.
Boop. There you go.
Hey,
It's beautiful.
it's beautiful.
We
Nailed
have-
it.
Very cool.
We built an animator.
Very, very cool.
Okay, let's clean up all of this
Amazing.
this extra junk that we are.
Yeah, I'm gonna get rid of the debug trace thing that I've got in here.
Can you get it to not print the list of units at the end there?
We can have it print a single unit. I don't think we can actually hide the return value, but I think when we run it from the command line, it doesn't return the return value. I think that's a UCM thing. But we can remove the trace, I think.
Yes, I think I got rid of the trace.
Okay.
Oh, maybe I didn't save it.
Great.
Maybe
Okay,
that's
so I'm
part of my
gonna.
issue.
I just saved, so it should be in there. Let's update. Great, everything's working. Okay, I'm gonna go back to this terminal and we're gonna try. We're gonna do a clear, and then we're going to. Okay. Oh.
Moving down.
That could just be a weird Terminal glitch. I don't know.
I'm gonna call that an artifact of the terminal, not our program.
Well, now that I'm at the bottom of the screen, it'll work perfectly, right? Maybe.
Yeah.
Why does it take so
Yeah.
long? It should not take that long, I don't think, but I don't know.
What,
Unison is a little
to draw
slow.
the?
To draw the
I was
first
gonna say we
turtle.
could speed the turtle up. Gotcha.
Yeah, it's quite slow, but hey, we're not on the JIT runtime yet, so
Yeah, it'll be faster in the future, and it's a turtle,
It's a
not a
turtle.
hare.
That's
It's
right.
supposed to be slow.
it's
part of the
supposed to be nice
philosophy.
and slow.
Also, I think if you do put a unit at the end, I don't think it will print that. I think it's only printing that because it's a list of unit, which is not unit.
Oh, that's possible. That's possible.
Huh,
Let's find out.
interesting.
Let's see. Yeah, because that was added as part of a recent feature, actually, which is pretty cool, where you can actually run add.run, where you can say actually run this, and then whatever the return value is, bind it to some name, which is pretty cool.
I think also
Let's try that though.
like isn't there a function like for each or something that allows you to like basically run each element in the map in the list for effect?
And then return a unit. Yeah, there might be. Oh, so it does
I
still
might be
return
testing
a
it with
unit
an.
here.
Yeah, might be testing it with them because my version is not doing that. I wonder if I just got to update.
Yeah, so this is a very new feature. I think it might just be like the printing out of the return value is a new feature. And yeah, it only does that in UCM. And that's so that you can see what the result was, so that if you want to do add.run, then you can see what you'll be adding to your code base.
I
If
see.
that makes sense. Yeah. What was the other thing I was going to check? I don't recall. Oh, I think I was just going to push this to share.
Were you checking the unit printout?
Yeah, it does still print out the unit. Oh, I was going to look for a for each that doesn't print anything, but I think this does something else. Oops. My Vim muscle memory. Docs. Oh, it does return unit. Is that what I want? For each traverses the list X's. It's still a wonky argument order, but that might work. There we go. And then I don't need this unit. Yeah, it is a little nicer. And we'll update that. And then let's push it up to share. Not share.turtle. Oops. Push Chris Banner public turtle. It wants me to log in. Haven't done this in a while. There we go. Yes, I did mean push.create. There we go. And this will also have to add, I think, newest version of base and Stu's library, so that's going to take just a second.
Gotcha.
There we go. Great.
Awesome. Does anyone have any questions?
No.
Cool.
Now we
Great.
get to test our Unicode rendering in share. You got a turtle namespace? Love it. This is great. This makes me very
Amazing.
happy. Awesome. Sweet. Good job.
Yeah, good job,
I-
team. Thanks, everyone.
I don't know if we should go all the way or pull it back. This idea of using the emoji because we could do it for the right, left, and
Oh, do we dive all the way in? I love it.
I'm sure there are like clockwise and counterclockwise arrows emojis, right?
Ooh,
I think there are.
but I'm regretting this as I said it.
what have we done? Oh, well, we've got. Yeah. Yeah, we do. Well, we might have to get a little creative. Yeah, here we go. Anti-clockwise, clockwise. Ouroboros. Yeah. Cool. Well, definitely feel free to fork for full
Yeah,
emojification.
if you want
or
to
maybe
create
we'll
your
do that
own
next week.
turtle skin. Yeah.
Yeah, exactly. Sweet.
Yeah,
Yeah.
at
So
some point we may swap out the handler implementation for sort of a different graphical interface. So, because that's the beauty of the abilities. You can do that.
yeah. Yeah, and I think it'd be fun to also like try rendering to a bitmap or something like that, which I think we could figure out pretty easily.
Yeah, that would be cool.
Yeah. So if
Potentially
anyone
for
has
next community day.
if anyone has ideas, put them in Slack, and we'll consider picking those up in the future.
cool.
Great. Well, thanks for chiming in, everyone. We'll put this up on YouTube probably sometime soon. And I just pushed the library to my share, so I will add a link to that in the Discord, and I assume we'll probably also post it in Slack somewhere. So that's where that's hosted.
Cool. Thanks so much, Chris. Thanks for everyone for joining.
This is super fun. Yeah.
Yeah. Until
Yeah,
next
thank you.
time.
It was very fun.
Thank you, guys. Bye-bye.
Bye.
Catch y'all next time.
Bye.
Bye.